Hey guys, Mr. Grand here, Exponent Properties Day 1. So just a little bit of a review of the exponent properties that we're going to be using throughout the class. Alright, so we're not going to go through every single one of these because that'd be a little time consuming, but our product rule, when we're multiplying two bases together that are being raised to exponents, if you follow my dot here, right? Remember that an exponent is really sort of a shortcut method of writing, like in this case, 5 to the second is 5 times 5, right? So that there's two 5s, and 5 to the fourth is 5 times 5 times 5 times 5, so there's 4 of them. So if I write out the whole thing, 5 times 5 times 5 times 5 times 5 times 5, it is 5 to the 6th power. So it's really the 2 here plus the 4 here, and this is where this product or this property comes from, that if you are multiplying the same base that's being raised to exponents, that you add the exponents. So just to go through one of these real quick, so the next one down, 2 times 2 to the 6th would be 2 times, and then 2 times 2 times 2, 4, 5, 6. And we could count them all up. Now there's 7 total, so our short form, our exponent form, would be 2 to the 7th power, right? All right, so the next one, our quotient power. What happens when we're multiplying a number raised to an exponent, or when we're dividing a number raised to an exponent? So now 3 to the 4th, in our long form it would be 3 times 3, so there's 4 of them, right? 3 squared would be 3 times 3, so there's 2 of them. And what happens in a fraction when you have a matching number on top and bottom is they cancel out. So we could cancel out 2 of those 3's, and what am I left with? 3 times 3, which would be 3 squared. So that's why this rule works the way it does when you have a quotient that you're subtracting the top one from the bottom one, and it's to the m minus n. All right, so then for example, to just do another one of these, 10, you could conceivably write this out the long way every single time if you wanted to. Although if you can get to the point where you don't need to do this, they go a lot faster. All right, so now we can cancel out the ones from the top and bottom, and I'm left with 10. I'm left with 3 10s on top, so that would be 10 cubed. So either way, you could write it out the long way like this, or you could just subtract the 2. Doesn't really matter. All right, next one, the power of a power. So this is students sometimes mix up this property with this property when you're multiplying two bases versus where you are raising something that's in parentheses to a power on the outside. So there's an exponent on the inside and the outside of the parentheses. This works a little bit different, and here's why. If I take this 5 to the 4th and I square it, that thing in parentheses is 5 times 5, so there's 4 of them, right? So over here in the parentheses, I've got 4 5s. This set of parentheses, I've got 4 5s. The thing in parentheses is being squared, so there's 2 of these sets of parentheses. And so if I add up all of those 5s, there's 8 total, which is 5 to the 8th. Now the shortcut method there would be to just multiply. I've got 2 groups of 4, so 2 times 4 is 8. And that's where we get this property down here, if you follow the red dot, that if I'm taking the power of a power, that I can multiply those. All right, so just to do one of these, we'll do the m one. So it's m squared in parentheses. So every set of parentheses is going to be m times m. Now I'm taking that set of parentheses and I'm raising it to the 4th power. So it's going to be 4 of these groups of 2 m's. And when I'm done, I've got 2, 2, 2, and 2. That makes a total of 8. So that would be m to the 8th, similar to the top one. All right, some other ones that we're going to be doing. This one is sort of a distribution rule. So if you have more than one thing inside of the parentheses and you raise that to a power, that power goes to both of the things. It distributes into both the 6 and the 5 in this case. And you can see that you're taking what's in parentheses and you're cubing it, so there's 3 of them, right? 3 sets of parentheses. Well, then I've got 3 total 6s, so 6 cubed, and 3 total 5s, so 5 cubed. We can kind of do the same thing here with the next one down. 2x is inside the parentheses, so it is 2x times 2x times 2x, so that there's 5 of them. And so if I do it the long way like that, now I've got 5 total 2's, so 2 to the 5th, as well as 5 total x's, so x to the 5th. And this is the one that students really tend to make mistakes on, is that they don't apply the 5th power to the 2. They only apply it to the x, and they say that this is equal to 2x to the 5th, when actually it's 2 to the 5th times x to the 5th, which is like 32x to the 5th. Okay, a few more of these. So this is kind of the same thing as the last one. Whenever you have a quotient and you're applying the exponent, right, you're applying it to both the top and the bottom. So that's what this says, is we can distribute that n into both the top and bottom. And students actually don't seem to make as many mistakes with this form. But in the long form, you can see I'm taking this fraction and I'm multiplying it 4 times because I'm raising it to the 4th power. And then if I separate, the top and the bottom, the numerator and the denominator, I've got 2 to the 4th on top and I've got 7 to the 4th on bottom. So similar with, let's go down to the bottom one here. W over y times w over y, w over y. That's our long form. And then if we, sort of simplify that, it would be w cubed over y cubed. All right, so the next one, this is anytime you are dealing with exponents that are negative. You can change the exponent to a positive and then flip the fraction. And oftentimes the way a problem will be worded is it will say, express this as a fraction with no negative exponents. All right, so what would happen here is for 4 to the negative 1, right, I can make that into 1 over 4 to the positive 1, or just 1 over 4. 5 to the negative 2, that's 1 over 5 squared, or 1 over 25. 10 to the negative 3rd, hopefully we're getting the idea here, 1 over 10 to the positive 3. And then when you have an actual fraction where you're starting with it, right, you just flip the fraction. So this would be 3 over 2 to the positive 1. And with that last one, we could either make it 4 over 7 to the positive 2 like that, and we could simplify that a little bit further and make it 4 squared over 7 squared like that. All right, last thing. Any number to the power of 0 is 1, except 0 to the 0 power, which is undefined. So anything like, if we did 3 to the 0 power, that would equal 1. X to the 0 power, as long as x itself doesn't equal 0, is going to equal 1. All right, if you have any questions, email your teacher, and have a great day.